Welcome back to Mr. Sindel's class. All right, so we're on Unit 2, Pretest. This is derivatives, so let's go to number 1. All right, so number 1 was one of the harder ones starting right off, so I'll label these two. So we have this function which must be true, and we haven't actually seen this in our notes yet, but this is actually another type of definition of derivative.
Well, how are we supposed to know that then?
So...
Yeah, good one, Mr. Sindel.
I'm just going to read your mind.
All right, so you should kind of see that you have a function and minus another function, and the denominator here is 0. This sounds very familiar to our definition of the derivative that we already know, where we have a function minus another function where c is actually subbed in, and then the bottom goes to 0 if I subbed in the value of 2. So this is the derivative. So if you were able to recognize this is the derivative and it equals a number, that means that it's differentiable, that I can find the derivative at this value, at 2. This is saying I'm going to 2. And you can kind of think of this as our graph. So you have some weird function, and you say, okay, I'm trying to get closer and closer to 2, or to some value. And then you say, okay, well, I don't know what I'm doing here, but I should have done like a curly brace here. Let's see if I can try it again. I have some distance h, so this value here on my number line is 2 plus h. And right now, if I drew a line through here, that would be a what line? It's not a tangent line, it's called a secant line. There it is. So if I drew a secant line and I get h and h closer and closer to 0, so that 2 plus h gets closer and closer to 2, I'm getting closer and closer to the derivative. And that's kind of what this is saying too. As I start with 3 or something in the denominator is quite large, just like h was large, and it gets closer and closer to 0. This is the definition of the derivative still. All right, so which of the following must be true? This limit does not exist. So most people would say, oh, that has a 0 in the denominator cannot exist, but no, that's not. This is the derivative. It does exist. F is not defined at x equals 2. So for the derivative to exist, you have to be defined at 2. So this is the opposite of true. So the derivative of f at x equals 2 is 0. Yes, this is the definition of the derivative. So the derivative of f, that is this part right here, and this is saying at x equals 2, yep, x is going to 2, is equal to 0, is 0. So
wait, can we write that out like in more detail? Sorry.
Write it out in more detail. So this is
yeah.
So this is another type of derivative, and we can say that when I have this form, this value here is our c. When I don't have h goes to 0, when I have x goes to something, and I have two functions on the top, so two functions on top. When I see two functions on the top, I should be wary that this is the definition of the derivative. Two functions on the top and a 0 on the bottom because x goes to 0. You should think...
But that means derivative.
Think derivative, yeah. And you have to figure out what c are they asking for, because it's always f prime of a number, f prime of c. You could say, what is f prime of 3? I don't know what the number is. What is the only thing that logically makes sense for c to be in here?
2?
2, right. So c is 2. So the derivative at x equals 2 is 0. F is continuous at x equals 0. So this one, we don't know what happens at x equals 0. We know what happens at x equals 2. It's definitely continuous at x equals 2, but we don't know anything about this x equals 0. We don't know, so it might be true, it might not be true. We're looking for a must be, though. And f of 2 equals 0. So when I go to the value of 2, what is this asking for? Is this derivative? Is this height? What is this saying?
Height.
Yeah, this is saying that the height of 2 is 0. Well, no, this is the derivative at 2 is 0. This is the slope equals 0, so it's not this one. This was asking about height. All right, let's move to number 2. All right, so again, I have two functions. This one has been evaluated for us, and I have divided by h, so what is this thing here? Some sort of definition?
As h approaches 0 on both sides.
Yeah, it's a double-sided limit, I agree. But more specifically, it's the definition of something.
Or
Is it
I
a
mean-
box? Oh yeah, it is.
This is hotbox because this is the definition of the.
Product? No.
Starts with a D.
Derivative.
Derivative. This is the definition of derivative. So hotbox it. So hotbox.
Carly does it.
Carly claims her credit. Hotbox the values with the largest amount of things in them. A good thing to point out is if I have something plus H, that's what I'm going to box. So hotbox says I only worry about the stuff in the box. Don't worry about anything else. Don't worry about this limit. Don't worry about the H. Don't worry about the -1. So hotbox also says cross out the stuff in here. I'm going to do that with my highlighter. That way we can still see it. So cross out this stuff in here. Okay, that's a little bit big.
Whoa.
Let's change the size of this. Cross out the stuff in there and then turn that into what?
X.
X. And that is our function, right? Our function f of x is what?
ln of x.
Natural log of x, yeah.
And like over h or g.
Oh no, don't worry about it. Hotbox eliminates all that. Only worry about the stuff inside the box.
Oh, I get it.
And what was C? What was the value that we're evaluating? Yeah, C is E. So, and then I'm going to have to find f prime. I'm going to have to find the derivative, but we don't really care because it already says we're finding f prime. So, which of these has the correct C value?
A or B.
A or B, you're right. So it can't be C, D, or E, and it's one of these two. Now it's asking for what is the function? And we know the function.
have it right over there. It's L of x, so it's A.
Yeah, exactly. So if you hotboxed it correctly, this one was pretty straightforward. All right, questions on 2?
No.
All right. Questions on 2, other girls?
Am I crunching over there?
No.
No.
I can hear digging into the goldfish or whatever it is. Wait, we're not allowed to have food in the classrooms.
Oops.
Yeah, put it away. Box it up. Totally forgot until you mentioned it. All right. All right, so this is going to be problem number 3.
I don't think they can. Oh, wait. Yeah, they
What am I doing for problem number 3? Girls, problem 3.
Okay.
What does this d dx mean?
Derivative.
So I'm taking the derivative of this, that's the first step, and then I'm going to plug in this -1. So how do I take the derivative of this?
You're gonna
What
get
I-
rid of the.
What I like to do is find the inner and the outer. Are there any inners and outers in this?
Nope, there's only outers.
Oh.
So you gotta get rid of the fractions first then?
Yeah, in calculus we hate fractions because that means quotient rule. So let's get rid of this so we don't have to use quotient rule. How can I rewrite this first term without a fraction?
Wait, and then do we know not to use quotient rule because there's 3 x's, not like 2?
And that's another pointing factor, yeah. There's 3 things in here, so you're probably not going to be using quotient rule. So d dx, the derivative, how do I change this first term? I want to get rid of the fraction. What do? I don't want it 1 over x cubed. I want it something else. Use negative powers here.
Negative 2x squared.
I'm not taking the derivative yet. I just want to change it before I take the derivative.
X to the
Negative
negative
x.
3 power.
X to the -3. Yeah. And then I'm just going to put my parentheses here. This is going to be subtracting. Rewrite this one without a fraction. Second term without a fraction.
X to the -1.
X to the -1. And I don't have to worry about my third term because it's not a fraction. Now I take the derivative of each of these individually. Remember, we distribute this derivative into each of these terms. So I'm taking the derivative of x to the -3rd, and that is what?
-3 to the -4.
-3x to the -4.
So that's
And then next term, go.
Negative 1x.
so plus x.
Yeah, there it is. Double negative, right?
Plus x minus 2.
Plus x, what is it to the power of?
Minus 2.
-2, okay. Sorry. I did hear you say that, but I thought you were talking about the third term. And then final term is?
2x.
Plus 2x. Yep. Okay, now I'm subbing in x equals 1 into each of these x values. So I'll do that saying -1, -1, -1. That goes into our values of x. And we have to be careful because what is -1 to the power of -4? And to think about that, I'm going to do this off to the right-hand side here.
I think that's what screwed me up. Is I was good to that point, and then I started messing up my.
So keep track here of your parentheses. Parentheses will mess you up. When I sub in -1, whenever I substitute, I keep parentheses around whatever I substitute in. I'm substituting all of -1 into this value. If I didn't do my parentheses, then you will get the wrong answer.
It's just now your phone's ringing.
Carly, go for it.
Calling about the
Can I get
food, I bet.
All right, we're going to continue.
Carly, get it. Oh, I thought he said get
Oh,
it.
never mind. All right, so this -1 to the -4, what is
I
this?
feel like I'm being a little aggressive.
Girls, what is -1 to the -4? How do I write this without a negative in the exponent?
Bring down the so like you would have -1 over 1 to the 4.
So
or 1 over -1.
yeah, you do 1 over whatever this was to the positive power, and I keep my parentheses.
Okay.
Okay, now if I have my parentheses around the negative does have a chance of going away. Does it? Does it turn into a positive, or does it stay a negative?
So what's the
Positive
rule on
because
that?
it's an even number.
Yeah.
Yep, positive because there's an even exponent. Beautifully said.
In scale.
All right, so this turns into -3 times +1
Yes, sure, Mr. Sin, I was like,
plus.
so like when it's an even number, what does it turn into? And I was like, an even number. And then I'm like,
That, yeah. Okay, second term. Do it for me, girls. -1 to the power of -2. Go ahead and see this in your head, and the answer is...
X.
Well, we're plugging in -1 for x. So is it positive or negative?
Positive 1.
Positive.
Yeah, it is +1. And then we're going to add, and then what is this going to be?
-2 or -2.
-2. All right, so now this becomes pretty straightforward. -3 plus 1 minus 2 is?
-2.
-4. There it is.
Wait, so where did I screw up on this?
It's just I feel like when we're in a time rush, like I really like to take my time with like the negatives and stuff like that. Otherwise, I screw up and then like I'm doing everything right, like up until I have to like simplify or do something like this.
That's good though that like you at least know the
Yeah,
process.
yeah. So you understand the broad concepts, but yeah, we'll work on our math
It doesn't do
skills.
anything if I'm getting them wrong. It sucks.
Yeah.
We'll work on it, Rosalie. Do we have questions on 3 before we move to number 4?
No.
No.
All right, so here we go. Number 4. So let both these be differentiable functions, and it gives us a bunch of values that we can use, and we have h of x is equal to f of g of x. And we haven't seen this before, f of g of x, but we kind of have in a more explicit form. And I'm just going to go ahead and come out and say it. This is an outer and an inner. There's an outer function, and there's an inner function. So when I have an outer function and an inner function, what do I multiply? So if I say h of x is outer, oh, I do not know how to spell. H of x is equal to outer and an inner, which is what this is really saying. Then h prime of x, when I take the derivative, this is equal to,
And don't we have an inner too? Because the x.
sure, but the derivative of x is
1.
1. So you're correct, there is an inner, and that's where it stops. So we don't really need to do it, but it is 1. All right, so h prime of x, answer this for me. What is this equal to?
Doubter
Doubter
times dinner.
times dinner. Exactly. So what is doubter in terms of f and g, right? I don't want to write doubter. I want to write f prime something something something. What is doubter?
Nobody's perfect.
It's f prime of everything inside.
F prime of everything inside, and what goes inside?
G of x.
G of x. Perfect. And I'm going to multiply this by dinner. What is dinner?
When you're finding doubter, you always put what's in it. Like they're not gonna leave a parentheses open on doubter.
Right. That was just for our worksheet where we left it open. So dinner is
G of x.
G of x. Close.
What?
I'll read it here.
GX prime. GX prime.
Oh my bad.
G prime of x, yeah.
G prime.
Times
I
one.
tried.
Because we take the derivative of g, which is g prime of x. Perfect. So now we have our basic setup. Now we need to use these values up here to substitute into what we have. And remember, what is the x value that we're subbing into both of these? What goes in here?
I don't like.
What'd you say, Rosalie?
1.
1. How'd you get 1?
I'm gonna start crying.
You got 1 from here, right?
Yeah.
Yeah.
All right, so when I plug in 1, I need to find g of 1. So what is f of g of 1? Or f, I just want to do f prime of, what is g of 1?
3.
G of 1 is 3. Perfect. And then what is g prime of 1?
-3.
-3. All right, what's f prime of 3? F prime of 3.
Oh.
Negative 5.
-5.
-5 times -3. Our final answer is
15.
15. There it is. Questions on number 4. Oh, did you finish, Isabel? All right, so I still need to grade your test, or your pretest. So you can write, use like a pen or pencil for your notes if you're correcting it with us. But I still need to grade your pretest. Do you need a pen? Do you need a pen? I have a pen over here if you need to borrow it. All right, we're on to number 5.
Yeah, the negatives always have.
All right, so f of x is equal to e to the 1 over x. All we're taking is the derivative. So derivative of e to the 1 over x is what?
E to the 1 over x.
E to the 1 over x. But that's not an answer, so obviously there's more.
I don't like your test.
Oh.
So your doubter is just going to be the same thing.
Yep, doubter for e house is same thing.
And then times, so you have 1 over x, so you bring up the x, so you have 1 times x to the negative 1.
X to the negative 1, okay.
And then to find the derivative, you have negative x to the negative 2.
Negative x to the negative 2.
So in this one, you just need to remember dinner, and then...
Yep, remember dinner. So we had doubter, dinner, and then we can simplify dinner a little bit to make it into one of these forms. So this is going to be equal to e to the 1 over x still for the numerator. The denominator now is going to be what?
Negative x.
Over x squared.
X squared, and don't forget that negative, so we'll put that negative out in front. So negative e to the 1 over x divided by x squared. Where is that guy? Right there.
A.
All right. Questions on number 5?
Wait,
How do you get negative
I see.
x to the negative 2?
How'd I get this thing? Kaylin, explain it for us.
Okay, so like you're taking the derivative for inner, so you're taking the derivative of 1 over x. So then you can't have a fraction, so you bring up the x to get x to the negative 1. And then so it would be 1 times x to the
Oh, I
negative
get it. And then you just do minus 1.
Yeah.
Yep.
Okay, I get it.
Turn it into not a fraction, powerhouse. Perfect. All right.
But then how'd you get it negative?
Because you bring down the negative 1.
Oh, okay.
Yeah, exactly. Rosalie, you good?
Yeah.
All right, number 6. So, which of the following must be true? What is this thing? This giant thing here. It is the definition. What is this thing here?
I don't know.
I heard that.
Just kidding.
I said mother trucker.
Okay, sure. So,
I did. I said it.
okay.
I don't just say that, Mr. Sandell.
What is this thing?
Hawk.
We've already talked about it before in number 2.
Box.
It's hotbox to solve it, but what is it?
Ah, frick.
Derivative?
Definition of the derivative. Yeah, it is the derivative. And it's one of the definitions that we need to know. All right, so for this one, since it is the derivative, and we say the derivative is equal to 5, what is the adjective that goes along with derivative? If I can find the derivative, the function is...
It has a slope.
has a slope. But what...
Differentiable.
Yeah, differentiable is the adjective that we attribute to the derivative. So if we found the derivative, it obviously is differentiable. And if it's differentiable, that implies
It's continuous.
it's continuous. So 1 and 2 by default. All right.
I got it right.
And then number 3, so this one is a little bit confusing. The derivative of f is continuous. So we know that f is continuous at x equals 2, but we don't know that the derivative of f is continuous. That's saying that the way that the slopes change in the function, the slopes have to be continuous, which is weird because normally we only think about heights being continuous. You make sure that everything is connected. We don't know anything yet about the slopes being continuous unless we go into the double derivative, but we're not doing that yet. So we don't know this. Yeah, not yet. So we don't know 3 yet. And there's no way to actually apply it to just the derivative, so this is a might be true. So 1 and 2 are must, and 3 is a might, so where's 1 and 2?
Can't
C.
you solve it to figure out if it is x equals 2?
He just said we're not doing double derivatives.
So there's no way to actually calculate the double derivative here. It doesn't tell us what f was, what the function was.
I got it right. Just saying.
All right, number 6. Are there questions on 6 before I move on?
No.
Waiting on Rosalie?
Yeah, I'm good.
You're good? All right.
I was just confused. Okay.
Let's go on to number 7.
I didn't realize it.
All right, so we have our function. It's equal to this guy. Remember that cosine. Sorry, I don't know. I wrote that. I'm thinking ahead. Cosine cubed of 4x can be rewritten as what?
Cosine.
3 cosine or?
Cosine 4x
Cubed.
cubed, exactly.
Oh.
That's the right way to think about this
I thought you were
function.
doing the
I know.
derivative.
And I somehow thought it was like inner, outer. It is, huh?
So this one has an outer, an inner, and an inner. The outer is to the power of 3, the inner is cosine of 4x, and then the inner is 4x.
Cause cosine.
So I can even label that for us if we would like. So this is the outer,
Wait, I just did it wrong.
this is the inner,
Cause the derivative would be.
and this is the inner in there.
Outer.
All right, so let's find doubter. What is doubter?
3 parentheses. Okay, wait. Here, I gotta catch up one second.
That's fine.
3 parentheses of cosine. Parentheses 4x.
4x,
Parentheses.
And then a 2.
yep, to the power of 2. And we can rewrite that in terms of cosine squared of 4x. So we'll write that in when we simplify it down here below. Okay, we just did doubter. What are we going to multiply by? What's next?
Negative sine 4x.
You're doing dinner, so negative sine of 4x. I agree with you. Okay, are we done?
No.
What do we have to do? Okay, what is that?
4.
All right, there's our dinner inner. Simplifying this a little bit, so I can pull the 3, the negative, and the 4 to get what out front?
12.
Negative 12, and we're done. Like, once we see negative 12, there's only one answer that has a
I
negative
thought we were
12.
somehow gonna bring the squared in.
And I'll go ahead and simplify this for us. This is going to be cosine squared of 4x times sine of 4x. And that's exactly what we have up there, barring the parentheses that we added. All right, cool. So grab that, grab a pen or a different color or something so you can take notes with us. I still need to grade that, so that's mine today. So Isabel, you too. Yeah, go ahead and steal a pen. You don't need to give it to me yet, but just remember, by the end of the day, that needs to be in here.
Mr. Sindel, how is it negative 12?
Good question. Someone else answer.
Because that's
You can hold on to it and take notes for now.
Oh, I was taking notes on my notebook.
Oh, that works. Okay. All right. Did that answer it?
Yeah.
All right, cool. Other questions about 7?
No. Actually, I'll take it.
All right, moving on to number 8. All right, so we have this guy. We're asking, is it differentiable? So we can only check right now if it's continuous because we only have f of x. So let's check if it's continuous, and then we'll check if it's differentiable. Oh, we're going to assume. Okay, so we're going to say if it is differentiable, differentiable implies continuous, right?
Yes.
I should have asked that as a question. Differential implies continuous. So we assume that this is continuous, and we assume it's differentiable. So assuming it's continuous, what do we know about this top function and the bottom function? What can we do with it?
They equal each other.
They equal each other. E to the negative x plus 2 needs to equal ax plus b. And then what are we going to do with these x's? We need to find a and b, so something has to happen with our x's.
Plug in.
Plug in what?
0.
0. And what do we call 0 in our class? Starts with an S, suspect point. Exactly. So we're plugging in our suspect point of 0. So we have e to the negative 0 plus 2 is equal to a times 0 plus b. All right, solve. What is this going to be? E to the negative 0 is?
1.
Are you sure?
0.
0 or 1?
1. I'm sure.
It is 1.
Don't try to
I was just making sure. 1 plus 2 is equal to, what is this going to be on the right?
3. Oh, sorry.
Rosalie's jumping ahead. I found it. It's 3, Mr.
Can I
Sindel.
get a cough drop?
Go for it, yeah.
Because I didn't.
All right, so we found b equals 3, but we can't find a until we do what?
Plug it in.
Plug it into what?
A x plus b.
If we plug in b equals 3, we're just going to be equal, ax plus 3 is equal to a bunch of garbage still, right?
Oh yeah.
I mean, we can try. I'll show you why it doesn't
Plug
work.
back into the original equation, negative e.
We want to plug it back into here?
Oh yeah, but you don't have e. Well,
Yeah, so because a cancels out still if we have e to the power of x.
Set the equation equal to 0,
You
and then
plug it in for 3 and solve for a.
But we don't know that it equals 0. We just know that it equals the other side. So remember, the key word here is differentiable. This was all continuous. How do we get the differentiable side? What do we do to this function? I'll give you a hint here. F prime of x.
Oh, yeah. I totally forgot about this.
All right, what's the derivative of the top?
E to the negative x times negative 1.
I'm just going to put that negative 1 right there. Is that cool?
Mhm.
So negative e to the negative x. Is there more here?
No.
Okay, what's the bottom equation?
It's a.
Just a. All right, again, set top equal to bottom, the left part equal to the right part. Negative e to the negative x is equal to a. And what do we do to get rid of that x, that pesky? I don't even know.
Equals 1.
Pesky. So negative e to the negative 0 is equal to a. Therefore, a is equal to
Negative 1.
negative 1.
No, I did get rid of
Therefore, a plus b
Equals 2.
equals 2.
I did something completely different, but I messed up.
Yeah,
I
I
just
did
said the right answer.
Well,
I did
kinda,
too.
I kind of gave up when I got to 3 because I didn't know how to get a. So I was like, well, maybe a is 0.
Maybe
So I
we need
didn't-
corn nuts in here because I can't sell them in the booth. They're like I just opened the whole box. It was like left in there, and I can't sell them in the booth because the date is out. But they last forever, so I've been passing them out. But
I'll
you
have
like
some
one?
actually.
Wait, Mr. Sandella is still calling.
Oh, sorry, I'll go back. Remember, you cannot eat in the class, so you can hold on to them.
You could take them with you, yes. I don't know what else is left in here. Plain barbecue.
Oh, that's like original.
Can you throw me one too, Miss Mary,
Would
please?
you like plain barbecue?
Barbecue?
Wait, what's the? Can I see what the yellow one is?
The other one's
Thanks.
like a picante spicy.
That might have been loud on the
Oh, I think I'll
microphone.
just, yeah, take regular.
All right, Rosalie's pen is still going.
No.
Nope, okay. On to number 9. Numero nueve. Whoa, what's going on?
Oh my god.
It wasn't me. Like my pen just wanted to be held down. Number 9. All right, so we're taking the derivative of this thing. Okay, so derivative of a natural log, what do we do?
Put it over
1 over 1 over x squared minus 1.
Okay, so this is saying 1 divided by 1 over x squared minus 1. Would you agree?
Yeah, so you do the flippy thing.
So what are the rules when I divide by a fraction?
Flip it, change it. I don't know.
Keep it?
Keep it, change it, flip it.
Keep it, change it, and flip it.
Yes! Just learned that this morning and I
And when I multiply 1 by this thing, my final answer becomes...
X squared minus.
I'm going to leave it over 1, even though it could be just x squared minus 1 on the top and nothing. So there's really a shortcut for natural log. While it is true to say 1 over whatever is in here, what you're really doing is the reciprocal. So I take the reciprocal of the inner, which means just flip the inner, and that is the derivative. That is the shortcut. So look here. We had 1 over x squared minus 1. The derivative of natural log is the reciprocal of the inner. The reciprocal of the inner is just x squared minus 1.
But Mr. Sindel, don't you have to multiply by the
Yeah, what are we forgetting to do?
inner?
So we had doubter. Doubter was equal to this. Now we need to multiply by dinner. So x squared minus 1 is doubter. Now we multiply by dinner. Dinner is what? And we have to be really careful about dinner. That's the hardest part about this problem.
Isn't it?
It's just 1.
What is inner before we get to dinner?
1.
2x.
It's 1
Oh wait, no,
half
just
I just want inner, not dinner.
1 over x squared minus 1.
Exactly. And I'm going to put parentheses around here.
Wait, can you explain?
Inner is the thing inside the parentheses.
Because you took the ln of the inner. Is that what?
Oh.
So yeah,
Okay.
outer was natural log, inner was this thing. So this x squared minus 1 was doubter. Now we're going to work on dinner, but to find dinner we have to start with inner. Okay, now we found dinner. It's a fraction. Uh-oh. You're either using quotient rule or you're rewriting it as a non-fraction.
Okay.
So as a non-fraction, how do I do that? That is the same thing as...
Negative? No.
Negative x to the negative 2 power.
You have to be careful here. It's this whole thing
Oh.
to the negative first power. So this whole denominator, x squared minus 1, that entire thing to the negative 1. You have to bring the entire thing up or nothing at all. So now that we have inner, we can do dinner.
Anyways.
One second.
I'll give you time to copy this down. Inner, we change the fraction. How do we go from inner to dinner? From 0 to hero. How are we doing this?
Bring it up and then bring down the -1.
So bring down the -1 times,
2x.
careful, you're going inner already. All we're doing is dinner.
Then
So
negative.
just x squared minus 1.
X squared minus 1 to the power of,
-1.
nope, it's
Negative
powerhouse,
2.
-2, there it is. So we just did dinner. And you might realize, hey, there's this inner.
But you only figured that out once you get going.
I know. Yeah, we didn't know how many dolls Sophia had until we actually opened up the next one, right? Inner. So what's our dinner inner?
I don't even know what you said, but this was great. 2x.
2x. Okay. Now we have our derivative. Now we need to simplify this. And simplifying is also
I was
hard.
not even close to getting that answer.
Oh, good gracious, Mr. Sindel.
So I'm going to leave this term right here and this term right here in the numerator. So if I leave those in the numerator, I'm left with, I'm not going to distribute either. I'm just going to leave them. So it's going to be 2x times x squared minus 1. I'm going to leave those in the numerator.
Wait, I'm sorry, can you repeat that?
So right now I need to rewrite, this is the derivative. I need to rewrite the derivative to get it into one of these forms. Because right now I don't see any of these forms. So I'm going to take this term and this term, leave it in the numerator. But this term has a negative, so I'm going to push that down to the denominator. And I need to worry about this -1. Maybe I can just worry about that right now. Negative. Now I don't have to worry about it. So now I only need to rewrite this x squared minus 1 to the -2. I need to rewrite that with a positive exponent. How do I do that?
Just bring it down to the bottom.
Bring it down to the bottom. Tell me what to write on the bottom.
X squared minus 1 squared.
All of that quantity squared. Perfect. All right. I'll pause. Make sure you understand.
You can cancel one of those.
Carly's already seen ahead, but make sure you copy and then think about this. You can cancel one of these out. And how am I going to do that? Do you see what to do?
So then you would get -2x.
So there's one term up here and one term right there. So I'm still left with one of these terms on the bottom.
Yeah.
Yeah, but
So my final answer is -2x all divided by x squared minus 1.
Literally, all I did was forget my negative.
that was me too.
God.
Can we just get it right?
This was a really hard one.
This was, I agree, this was really hard.
This was a really hard pre-test. Is this how our real test is gonna be?
Wait, so
These are AP problems I'm pulling, yeah.
Why can't I just put them out of a floor?
It's fine.
They're easier.
I want to prepare you guys for the AP tests. All right, questions on 9.
And I erased it all thinking, oh, I got this one.
Questions on 9. All right, moving on to 10.
This one I just totally guessed.
I thought.
Why? Not again.
What the heck is going on with your pen?
Yeah. See, it's the pen, not Mr. Sindel. I like how she stated that. All right, so this table above is going to give us some values. We have this function. H of x is equal to all of this stuff. So what rule are we going to be using here?
I'm gonna knuckle you.
What rule are we going to be? Product rule. Why are we using product rule, Rosalie?
There's two X's.
Yeah, there's 2 x's. When there's 2 x's, you should be thinking one of two things. Oh, product rule, or oh, quotient rule. One is pretty easy to see from the other. Like, it's pretty easy to distinguish. Product rule is when you multiply, quotient rule when you divide. Product rule
X's, think what? Product rule
or quotient rule. So what is product rule? What is the cute little phrase that we remembered?
1d2, 2d1.
1d2 plus 2d1.
Ah, so neat. I marked you.
That cute little phrase.
All right, so I'm going to write down 1. This whole thing right here is 1. This whole thing right here is 2.
How do you know that? Oh.
Because those are the two things that we're multiplying. All right, so 1 is 2f of x
Can we plug f of x in though?
plus 3. Not yet. I just want to rewrite the rule. And I'm going to multiply that by d2. Someone do that for me. What is d2?
It would be g prime of x.
It would be g prime of x. Okay, I'm going to add. I'm still following the formula. I just did 1, d2 plus, and then what am I going to write here?
1 plus g of x.
1 plus g of x. This is all going to be times what? 2f prime of x. It was said lightly, but it is correct. All right, now we have our correct formula. Now we need to start plugging in. What do I plug in for x? What is our c?
1.
1. So 1 goes into each of these. So what is f prime, or what is f of 1?
Is 3.
Okay. And then what is g prime of 1?
It is negative.
Careful here. G prime of 1?
G prime 4.
4.
Oh, G prime.
Plus 1 plus, what's g of 1?
Negative 3.
And what is f prime of 1?
Negative 2.
All right, now we simplify. 2 times 3 plus 3
9.
times 4.
Big number.
9 times 4.
32.
36.
Oh god.
1 plus negative 3.
Negative 2.
Hold that in your mind. What's 2 times negative 2?
4, negative 4.
Negative 4 times negative 2.
Oh.
8.
36 plus 8.
I'm not good at mental math.
Yeah.
44.
44. Thank you, Carly.
Dang it. I caught it wrong.
Yep.
I knew that from the start as well.
All right. Joey, grab a pen. You can do notes with us, but I need that by the end of the day before, or by the end of class before you leave. All right. We're on to number 11.
Well, if you want to know the truth, I got 18 on this, and that wasn't an answer, so
I got
You
18
just
on this
guessed.
I think I
too.
got 18 too. Well, I kept getting negative.
I kept getting a
switching
closest
over
thing to
and
what
over.
I got.
Did you guess
All right. We only have a few minutes left of class, so let's go to number
I
11.
guess negative 28.
What are you guys thinking about number 11? What should we do?
Closest one.
What should we do for number 11?
The product rule.
Why should we do product rule?
2 things.
There's a thing over a thing.
There's 2 x's. 2 x's means you're either doing product or quotient. There's no fractions, so we're doing product. Product rule. What's the little rhyme we learned?
1d2 plus 2d1.
Plus
Over
2d1.
I was about to say over it, logo.
Over Lolo. No, not quite. All right, so what is 1?
I think I got this one right.
What is 1? Rewrite it.
X squared.
X.
What's d2?
E to the x.
C.
What's 2?
E to the x.
What's d1?
2x.
All right, so now I need to simplify this. I need to factor something out. What can I factor out?
X.
I can factor out an x. I agree. What else can I factor out?
E to the X.
E to the x. I can factor both those things out. When I factor them out, what is left on the inside?
2 plus X.
X
Two
plus
X.
2.
I always forget to factor. Like, it's my worst
Woo, that's the first one I've gotten right.
It's so satisfying to like pull out the like X.
Yeah, yeah.
All right. Question on number 11. Questions on 11. 3, 2, 1. On to number 12. Number 12 is cool because you're basically doing the same thing that we did up here, but without a table, they gave you a graph, a different type of representation. All right, so h of x is equal to f of x over g of x. So what rule are you thinking of? There's 2 x's.
Quotient rule.
Quotient
I
rule.
didn't even think about it.
Tell me quotient rule. What is quotient rule?
High D low or low D high?
Low. Oh my god.
Oh my god, this was low. You're right.
Low D high minus
High D low.
high D low all over low low.
My grandpa used to have a dog named
All right, so when we do that, we get. I don't even want to write the g of x and f of x in here because that's going to be a waste of time. Low is g, high is f. So we need g of what number? G of
G of x.
5.
not x. What number are we subbing in? Yeah, 3.
What?
Joy has it. Yeah, g of 3.
Wait, where's G?
G is low. Remember, G is on the bottom. G is
I
low.
went to G.
And then what is D high? D high of RC.
F prime
So high.
1.
F prime of 3. Yeah, we're just going to write it out until we see it. Minus high. What am I going to write here? F
Please
of
just take
F
a
of 3.
breather for a sec.
F of
I gotta
3.
Catch up.
Wait. Oh. So
Wait, how'd you get f prime of is 3?
So d high, the derivative of high, derivative of the top, derivative of f of x is f prime of x, and we're plugging in 3 at the same time. Because we're doing h prime of 3.
Oh, so it always has to be 3?
Yeah, 3 is plugged in for all the x's.
Oh.
I'm not going to write x's over and over again. That's kind of boring. All right, what's going to go here? D low. D low is g prime of 3. Oh, I was going to write x, but that's not what I want to do. G prime of 3. And then all this is going to be divided by g of 3 squared. Perfect. So now we have to find out what these are. So we need a g of 3. And look, we have a g. And if I go to the x-coordinate 3, what is g of 3?
3.
So this thing is going to be 3. What is f prime of 3?
3 was just height.
It is height, yeah. So g of 3, I come up here, and the height is 3.
Did you do the height of 1?
F prime of 3 is not quite 1. I think you're looking at f prime of, or g prime.
X?
So f prime of, what is f prime? What is that in the graph?
Slope.
Slope, exactly. So we need to find the slope of f in this vicinity. So at this point right here that I'm looking at, right here, what is the slope right here?
You rise 1 and go over 3, so it'd be 1/3.
Exactly. So I went 1 down and 3 to the right. So 1 down is minus 1 or plus 1? And right 3 is plus 3 or minus 3?
Plus.
So the slope here is
Minus 1/3.
minus 1/3. So I'm going to plug in
No, I got it wrong. Wait, it's minus 1/3?
minus 1/3.
Is the answer?
No.
Oh, I was like.
Okay, minus. I need f of 3. What is f of 3? F of 3 is 1. It is the height at 3. So I'm looking at f. The height here is 1. All right, what is g prime of 3? I need to find the slope of this line. What is the slope of that line?
You rise
3,
1.
fall 3.
You guys, isn't it?
1,
One.
just kidding. Don't listen.
1 over 1, which is 1. Yes, you guys got it. So g prime of 3 is 1. All of this is divided by g of 3 squared. So g of 3 again is what? 3. 3 squared. So I need to do 3 times negative 1/3. That is equal to negative 1 minus 1
1
over 9. So this is going to be,
minus 2 over
Negative
9.
2 over 9.
Okay.
God.
The only thing
that is the end of class. I will continue this video tomorrow.